Okay, rectangle 6.4. What we're looking at is the properties and using the properties and how you can solve to find distances or angles, etc., within rectangles. Okay, remember all the properties of rectangles. Look, first of all, always look for the diagram. What are you given in the diagram? Well, from the diagram, A, B, C, and D are all right angles. AD and BC are congruent. It's got one little red mark. AB and DC are also congruent. Consecutive angles are supplementary. Well, if they're both 90 degrees, if you add A and B together, you'll get the 180, which is supplementary. And then the diagonals, even though it's not on this drawing, but it is on this drawing here, they bisect each other. They are the same distance, they bisect each other. But don't get confused with a square. They don't bisect at right angles, so be careful on that one. Okay, so here's a typical type of example. A rectangular park has two walk paths as shown. PS, which is the side of the park, is 180 meters, and one diagonal is 200. Okay, what are they going to do now is they're going to prove that PS is the same length as QS, but by definition they must both be 200, same as QR must also be 180. But as you can see, they substitute in here PR for QS eventually, and then obviously it's just showing you by proof that they are both the same length. Okay, and don't forget the question is asking about QT and ST. Well, obviously if they're both the same length, both of the half diameters must also be 100. Okay, so here's questions 1, 2, 3, and 4. We'll do a couple of these, so let's have a look at what you've got. Let's have a look at question number 1. QR, that's this distance from here to here. Well, don't forget, one of the properties is that both sides need to be congruent, so that's the same distance as PS, and it tells you here in the question that PS equals 7, so QR equals 7. Let's have a quick look at number 2. We're looking at the diagonal from S to T to S to Q. All right. Look at what's given. It tells you that half distance is 3 13/16. Okay, if that's half distance, well, you're going to add on to that another 3 13/16. And what you will find, you can add them together, and you will finish up with 7 5/8 if you collect the like terms together and simplify. And as per usual, straight away example 2, we bring in the algebra, and it's looking at two angles, and don't forget the properties, they must be 90 degrees. Okay, so each of these angles, if we're looking at the major one of J, K, L and M, they're 90 degrees. We've got bisectors, but they don't necessarily, well, we know that they're not going to be 45 degrees. Okay, so put your algebra together. Okay, the two angles that they gave you in the statement must equal 90 degrees. Okay, replace them, substitute in with your angles with what you've been given. Solve, and eventually you'll finish up with x equals 9. And again, make sure you read the question. Okay, in example 2 it says find x. If it says find the value of each angle, then you will take this and plug it into this one and then this one. And again, once you've got the answer to that, make sure you add them together, that little check to make sure you get 90 degrees. So this one is question number 5, and it's looking at finding the lengths. Okay, in question number 5, so it says that FD, so one diagonal is 3x minus 7. The other diagonal, EG, is x plus 5. Well, you know that they equal each other, so 3x minus 7 equals x plus 5. And unfortunately, that's a decision that you've got to make, so be very careful. Okay, subtracting x from both sides, we get 2x minus 7 equals 5. add 7 to both sides, 2x equals 12, divide through by 2, x equals 6. Is that the answer? No, it says find EG. So take this guy here and plug it into here. So we're substituting here on this side here. So instead of x plus 5, we're going to put 6 plus 5, which gives us a length of 11. Now we've answered the question. Is it worthwhile putting it into the other one? Absolutely. 3 times x minus 7 is 3 times 6, which is 18. 18 minus 7 is also 11. Quick check, it proves that your algebra is correct. Okay, part 2, which leads us into example 3, proving that parallelograms are rectangles. Okay, most students think parallelograms are sloped rectangles, not also necessary. As you know, we've just been doing rectangles, so prove that it is. Look for all the information that you're given for right angles, opposite sides congruent, etc., diagonals the same length. Okay, and in real world exercise example 3, they're showing it you by proof. But again, look for all the information that you are given in the statement. Okay, that's going to lead you into what you need to do as far as the question is concerned. So here's obviously a proof type question. So you know that you always start with what is given. Okay, well, it tells you that ABDE is a rectangle. That's given. All right, again, always start with what is given. All right, and that BC is congruent to DC. They're both given statements. All right, it's very easy to start off with what you need to. First good statement to start is, don't forget, it's a rectangle, but we're still talking about parallelograms. So do we need to do this? It's worthwhile just saying that it is actually the definition of a parallelogram. I'm just going to simplify that. Just quick and easy. Need to prove that this guy is also congruent to that. So AB must be congruent to ED, because we want to know that opposite sides are congruent. All right, so that's opposite sides congruent. And as in the question, they've marked these two guys, so we want to know that angle B and angle D are right, because they are part of the definition of rectangles. And obviously we have to go back to chapter 4, because don't forget we need to be looking at this triangle and this triangle. Okay, so we want triangle ABC, and triangle is congruent to triangle EDC. Let's keep the same parts together, and that's by SAS, remember? If you look at what you've got, AC must be congruent to EC, and don't forget that the cheat parts, CP, CTC, all right? Corresponding parts of congruent triangles are congruent. There's your proof for you. So here's example 4. Again, it's coordinate. And again, first thing when you're given coordinates is to plot it. As I often say to you, it makes it a lot easier. And again, what you can see they've done here, they've done the distance formula. You've got to do it 4 times. 2 of them must be the same distance and must be the other 2, because don't forget, opposite sides of a rectangle must be congruent. Okay, and then secondly, what do you also need to know? You want to know about the diagonals as well. Are they the same length? Well, again, we've got the distance formula again. Both of them are root 65. You've got 2 sides that are root 13, 2 sides that are root 52. You've just proved that it is a rectangle. Okay, so question number 8. Here's your 4 coordinate points. Very quickly plot your points. X is here. Y is over here, Z is down here, and W is over here. All right, join your 4 points together, Well, straight away, the moment you've joined it, you know that it cannot be a rectangle, but you've still got to prove it, because it says justify your answer using the indicated formula. It's asking you to use the slope formula. Well, if you put the slope formula in, Wx is 2/5, xy is -2, yz is 3/5, and finally zw is -5/2. Okay, and as you can see, none of the slopes, because if it was wx and y and z must have the same slope, and wx and wz would have the same slope. Well, none of these guys have, but you've still got to answer the question. The answer is no.